I have experience, but I learn every day something different because it's been a while, but I don't know everything. We learn together. And today I'm going to share with you my knowledge, the knowledge that I gained over the years for composites. Composites applied to the agri industry. But before, I would like to discuss Novapol. Well, Novapol is a resin manufacturer, polyester resin. We are in Espírito Santo State. In addition to the Novapol of Fabrica, the plant, we have the distribution company that distributes products such as vinyl ester, releasing agents, catalysts, fiberglass. So we offer the complete packages. So we offer the complete package in addition to the polyester resin. So I'm going to talk about processes and about all of our products. Something else. The doors are open for visitors. So if you are crossing and going to Victoria, we're right next door. We're very close by to the capital city. Come and visit Novapol. It's not because I've been there for 5 years, but it's a nice company with a very good structure, very well located. We develop technology. We have R&D in there, so it's really worth visiting us. The doors are open to you. Doors are open to clients, visitors, students. Feel free and come and talk to us. So late during my presentation, I'll leave you my information. Should you be there? Well, it's important. So enjoy. So, in addition to being a resin manufacturer, we should contribute to the success of our clients by means of our products, but also in the technical assistance that we offer. In addition to other products. Um, so the purpose here is exploiting biocomposite materials in the agribusiness. So we'll discuss applications and market trends as well. Well, I'm going to talk about the polyester resin before speaking about the composite. When we discuss the resins, there are two types of resins. They're more commonplace. The natural ones and the synthetic resins that are synthesized in the lab. The natural resins, I think you all saw those. The ones that we see in trees, as you can see in the picture. Sometimes, if there is a scratch on the tree, produces this lump, yellowish, jello-like. We have other types of natural polymers. Hair, nail, it's a natural polymer. In the case of the synthesized one, it's a lab resin. The lab resin can be done by condensation, by addition. So we use sterification to produce our resins. Speaking about the polyester resin, this product didn't emerge. Emerged a short time ago. The first synthesizing was 1870 by Leo Backlund, a researcher. It was not polyester, it was the phenol resin. And the phenol resin in 1870, 1900, was named after the scientist that did bakelite. Bakelite, in its simple presentation, is the handle that we use in pots. Well, we also have automotive parts. If you have a Beetle, there is a part below the gas pump that is called bakelite. It doesn't withstand high temperatures. It degrades at 600 degrees C. So there are specific applications for such resin. And as time went by, the polyester resin emerged in 1930. Also with the emergence of the fiberglass by Owens. And as of 1930, we evolved. 1940, 1942, they began manufacturing vessels using fiberglass polyester resin. And then in 1950, we had the evolution of the automotive industry, and some parts were made and they were corrosion resistant. And then in 1970, this also migrated to the civil construction market. And then between the 80s and 2000, pultrusion was developed among other applications, the filament winding, for example. And then in 2000, there was a top year for us, right? A milestone for the more advanced resins with mechanical properties that were highly improved at the time, just like a ester vinyl ester that resists corrosion. It has great mechanical properties and great thermal properties as well. Uh, it was a specific type of resin that is widely used because of its versatility. So you can shape it and mold it in different ways and produce different parts according to the process and the application. Polyester resin originates from oil. It's insaturated carbon-carbon double binds. So we use a reaction initiator. The market calls it a catalyst. So I'm going to rupture one binding site to start, the product. The catalyst, the reaction initiator, methyl ethyl ketone peroxide, or MEKP, MEKP. Um, Talking about the origin of the raw material to produce the polyester resin, it comes from oil and then from gas as well. And on the left, with the ethylene and the propylene, we can extract glycols. On the right, benzene, maleic anhydrous, and the phthalate anhydrous. From the ethylene, we obtain the monomer, the styrene monomer, that is the basic solvent for the polyester resin. And then from the raw materials, we synthesize the polyester resin that is insaturated polyester resin. So that's a basic example of the reaction that takes place for us to obtain the insaturated polyester resin, which is the reaction between an acid and a glycol. So there's ester being formed, there's the resin, and we release the reaction water. It's a simple reaction that takes place. It's quite basic, we find it anywhere, but it's highly objective. The water from the reaction, it's not disposed of, it's treated because of environmental reasons. It is contaminated water. So polyester resin is generated by reacting an acid and a glycol, and the water is captured. So at our company, we are careful enough because of environmental issues. We treat the water. We do not dispose of it in a river, for example. We don't want to pollute any system. These are saturated and unsaturated acids. The unsaturated acids, we do reactions in the first stage of the process for any resin. What will define what kind of resin that is, the resistance to weathering or to mechanical strength, that's the second part. I use saturated acids. They can be orthophthalic, isophthalic, terephthalic, or halogenated. Other raw materials, as I said before. So in this case, I showed the acids. Now let me show the glycols. It can be ethylene glycol, diethylene glycol, neopentyl glycol, and others. And I'll add them depending on the properties that I want to promote in that polyester resin. Styrene and the reactive monomers. It could be styrene or methyl methacrylate. They have different properties. They have differentiated properties, actually. In order to react with a polyester resin, as I was telling you, we need the catalyst, the reaction starter. But to trigger, I need metal. We use cobalt octoate. that's a promoter. The polyester resin will react with the promoter, but we don't want it happening all at once, so we add the inhibitor to hold the reaction back. So to activate the reaction, because the resin has been inhibited because of working time and because of stability issues, so we add the catalyst to start, to trigger the reaction. How about the versatility of the resin? Well, one of their characteristics is the molding. We can work with filler-based systems, filler to make it anti-flammable. We can produce synthetic marble, we can use it for pigmenting, we can add flame retardants or UV absorbers, de-airing systems. So as much as I want and the color that I want, I can do that. I can provide characteristics to the resin, mechanical characteristics, weatherability characteristics as well. So it's quite versatile in the case of the polyester resin. Showing the production. I do have this system as an example. We have the storage of the raw material. I have the reactors or the reactor, the dilution tank, and distillation. So when we produce the polyester resin, we add the raw material inside the reactor. We have a heating system, an agitation system, and everything happens here. So we explain the reaction and we have the formation of glycol and acid. The polyester resin is formed in here. So transfer this to the diluting agent. When the resin is ready in the pre-dilution, it's very viscous. I cannot transfer. I need to do pre-dilution. So in this diluter, we add components, and this is where all of the characteristics will be prepared. I check viscosity, gel time, I may add pigments, the time frame, the isothermal peak, or many other characteristics of the resin. So we adjust the resin according to the demand, according to a customer request. So we store and it's ready for the market to be sent to the client. Okay? I'm not going to focus here. These are just examples of the different kinds of polyester resin. Ortho, terephthalic, isophthalic, vinyl ester, or iso and PG. So whenever we're talking about resin, it's not a single type. They're not all the same with the same applications. Chemically speaking, there are differences. Mechanical properties are different, weatherability is different. It's not that resins are all the same. They all have their different kinds of application. They all meet certain needs of the market. So what can it really differentiate? Mechanical properties, as I said, the thermal distortion, temperature, the HDT, weather resistance, among others, that really vary. It varies whether it's fire resistant, flame resistant, chemically resistant. That will depend on the type of product. So fiberglass. I spoke about the resin, now glass fiber, just to give you a broad brush of this. Fiberglass, roughly speaking, it's a molten glass
In filaments, in threads, sometimes threads of a thickness of a hair, but they are threads of agglomerate that we can call roving. Can also be chopped agglomerate, also called matte. And that's what's going to give a reinforcement to our composite. Glass has a very specific characteristic in comparison to iron and others. It has the lightness. It's very light, it has resistant durability, its mechanical properties are also very superior, which facilitates and also serves as technical insulation. So it has many characteristics, but fiberglass has also characteristics that added to resins increases the resistance 5 3 5 times more in comparison to wood, aluminum, steel. So composites today can have, in comparison, can have a superior qualities, as superior to steel. Of course, that fiberglass composite will never substitute steel, but with several applications, it serves with excellent properties, especially in terms of corrosion. And then we go to composites. When we talk about composites, it's a term designated to talk about reinforced plastics, the case, resin, and fiberglass. There are reports of composites since the time of the pyramids, for example. We don't know exactly who invented composites. It's something that is very old, but in the who has never went to a Baroque church? It's a composite because it's clay, but it will also have bamboo, clay, bamboo, sometimes straw, sometimes sand. I think you all have the opportunity to know Baroque churches. Sometimes the walls are a meter and a half of structure. But out of curiosity, if you're going to check the age of the church, this church is in São Paulo. It's made of adobe. It dates from 1560. You can calculate how long has it lasted. It has underwent renovations, but has not dropped. How many years are we talking about? And if it was only made out of clay, how long would it last? So look at the age of the composite. I'm talking about straw, bamboo, and clay. Polyester resins, fiberglass, the mix, the composition, fiberglass per plus resin. There are many combinations. What are the advantages of composites? Mechanical strength, low weight that favors transportation, resistance to corrosion, because depending on what you're going to compare with steel or iron, it suffers corrosion. Composites do not corrode. Molding, I can mold iron in many cases, but I need to uh, heat it up to 1300 degrees. In composite, no, I can mold it at room temperature. I spend less energy and it's versatile. Through several systems, I can also change the composition of the parts. And now the Z bars are very trending. This shows the resistance of these composites. And where do we apply them? Several segments of the market, for example, civil construction, in aggressive environments, in the agribusiness, marine applications, transportations, for mode and fragile code. And talking about the process, we have processes such as RTM line, spray up through machines. It projects the shop fibers with resins catalyzed on the nozzles, pultrusion, hand layup, which is manual lamination, the classic process, filament winding, which is a winding system for manufacturing pipes and tubes, vacuum infusion, which is a closed system as well, very much used in marine applications, and hot pressing of my BMC, SMC, hot pressing, where I can shape more technical parts, sometimes automotive parts. Unfortunately, I cannot detail all of them, but I chose a more common, more simplified process. Pultrusion. Pultrusion is a very promising feature in the market. Brazil, it's getting stronger, but in Europe also, till 2027, we estimate a growth by 11%, and it can reach a market for $5 million, very promising. In this market, very promising also in saturated resins, vinyl ester, polyurethane, and other resins. So this is very important data for this market. And then protrusion, that means pull through. Through this protrusion system, I can shape different parts with different forms, different structures, it's according to the needs of the manufacturer, the type of mold. So I have a design here with different shapes, more rounded parts, more square parts, depending on the objective. What's going to define it? It's the mold. We talked about composites in general, but the protrude composites, what are the advantages? Well, it has the advantage, for example, the shape of a steel column. If I get the same part in steel and in composite, the protruded composite will give me high mechanical resistance, even sometimes even higher than steel, but in a lighter weight. So favoring transportation, also making maintenance easier. The product is not metallic, it does not conduct electricity, has resistance to weathering, does not absorb water, can be self-extinguished in terms of flame retardants. The type of resin that produces these composites, I get some reports of 60 to 80 years of useful life. The protrusion system is basic. Maybe some of you already know, but it's also good to review them. Sometimes there are details that will be interesting for you. I have a demonstration of a protrusion system where I have the fiberglass that we call roving that is pulled through the system. Here we have the matte rolls. Here I'm mixing two types of fiberglass, roving and matte. In the continuous systems, this roving goes through a resin tank, which catalyzed with BPO, which is a kettle system that is hot trigger. This is impacted with the fiber and it goes through a compactor equipment, a preformer. Then it goes to the warmed mode. It is heated at three temperatures. It is the inflow is 80 degrees, 140 in the middle, 180 in the output. As it's a continuous process, in the end automatically the part cuts the machine cuts the parts in the pre-planned format. They can go 1 meter to 4 meters. This is determined by the manufacturers according to the client's needs. Protruded parts can be produced in different colors. It accepts different colors in red, yellow, so on. Novapol has solutions for protrusion, several different types of resins for different applications with differentiated mechanical properties. Novapol P600 is a neophthalic resin for situations where I don't need high chemical strength or other superior mechanical properties. 869 is very appropriated isophthalic resin of high reactivity, usually recommended for process gains because we'll have more productivity with Novapol 869 for protrusion. 1870 is also neophthalic, but it has less reactivity. The final goal of the part will determine the choice. And after we have ester vinyl resin. We are dealers of so-called if you need a resin for protrusion that needs superior mechanical properties, that needs resistant to weathering and others, we recommend vinyl ester resins. And as I told you, what's going to determine the shape of the part is the mold. We can have several styles and shapes, as in a corner or type I, type U, and others. The machine is the same. I will only change the molds, the reinforcement, and the resin depending on the application. He's showing the protruded part We have a mix. Underneath we have the surface veil, matte roving, matte veil, which is the surface layer that, in addition to giving it a finishing touch in terms of the statics of the materials, also helps in the resistance to weathering. So it's very important. If you don't have the veil, in time the first layer is slightly degraded, but I'm when I mean after some time, I mean 5 to 10 years. If you have this surface veil, it will last longer. So we recommend it for any extruded application. Here's a more realistic photo where I have the roving system, MAC 450. We have synthetic veil and the resin tinted in yellow, a realistic part that I brought to you. And here we have some cases. When I talk about agribusiness applications, it's because we have the same parts being used in the agribusiness. In the agribusiness, I mean, sometimes this is geared toward plantations for fertilizing plantations. I had the opportunity to study 6 months of agribusiness. In fact, I had to abandon, unfortunately, to drop out. But before starting the course, I thought that agribusiness, the agri industry, was to plant seeds and to calculate fertilizers. The 6 months really opened my mind because behind agribusiness, there's a lot of things in addition to planting seeds and fertilizers. You have different inputs that can be biologics, it can be mechanical inputs, and also chemical inputs. When we talk about biologic inputs, we are talking about manure and also waste from other plantations used to fertilize the soil, limestone, mechanical or automotive inputs are other consumables, including parts for tractors, roses, irrigators, plastics, structures for warehouses that are also involved in the agribusiness. So it's not agribusiness is not made out of fertilizers, because today the big cultures they use equipment, tractors, harvesters, and others. And through the composites, we use this. We create this consumables and these inputs. For example, I need a warehouse to store my production. I can be made of composites. The roof tiles can be clear tiles made of fiberglass. Some example: staircases of wood-treated material, Z-bars, grids for flooring that are very much used in animal growing, in the case of the pork, or sometimes in beef production, bridges made of wood-treated materials, and also solar energy. That is also part of the agribusiness, renewable energy. And of course, I'm not talking about solar panels, but the structure of the solar panels that is made out of composed materials. So it's a very interesting market. And here I have some examples more geared toward agribusiness. Here is a storage warehouse. If I produce, I have to store it somewhere. And the example is a clear roof tiles. In some case, where the client is an industry that uses fertilizers, these fertilizers will emit vapors that can be corrosive. If they are stored in galvanized tiles, for sure, in time they will suffer corrosion. And in composites, we don't have this problem. It's a material that is very corrosion resistant. Corrosion reduces losses not only to agribusiness but other industries. In our own households, we spend a lot every 2 years We have to maintain our own homes, especially the gates. Every 2 years, our gates are peeling. Sometimes they are losing the original color, and sometimes they are rusting. So you must pay for a painter to come and paint your gate. This is all represents costs. As it's a corrosion-free product, you have some maintenance, but if you compare to galvanize iron, you galvanize iron have to paint in 2 or 3 years. A composite you have to paint in 10 years. So you have savings with efficiency. It's applied also to fences for animal production. It can be made of pultruded materials. These rods in the harvesters, they are made of pultruded materials. They are light, and of course they suffer wear and tear. But in pultruded materials, I have advantages: durability, lightness that is good for the machine, because cars today they have this challenge. The lighter it is, the more savings they produce. Parts for tractors, such as roofs, bumpers, and others, made of composites, but not in pultruded process by RTM, by the hot process, SMC or BMC. And also structures that can be made of composites for the construction of greenhouses. The case also geared toward the agribusiness. The agribusiness.
And it's not just that. These parts, they can be used for civil construction as well. But if we have a farm or a plant, we need an industrial shed, we need electrical power. I mean, the electricity panels, they can be made of composite. They are made of composite today. And these pictures were taken from our clients. So our clients produce and supply these materials for the agribusiness. We have, transportation systems for pigs, identification shelters, signage shelters for industries, and I mean the shelves, they were made of iron. They would get oxidated. We can use protruded profiles and do the shelves. So a metal one will corrode. So you will have to replace over time. With composite, no. So it's a well-structured composite that can last up to 30 years with a high strength, or even more than 30 years because it's protruded. And closets and lockers. If you have an industry or a farm, you need employees, you need dressing rooms, so fiberglass lockers. They are usually made of metal, but then they will oxide over time. So either they have to be replaced or painted. So hardly ever we're gonna replace those over time. So here I'm showing to you some of the parts that were made by the RTM system using the Novapol resin. So if we look at this, if we look at the part, we see high glow, it's glossy, it's not wavy or warped, the surface is perfect. It's Neopol 491, low contraction rate, used for automotive application. Because it has low contractibility, it results in this kind of surface. High gloss, no deformation, no waving, and it's approved for the automotive industry, especially tractor manufacturers, among others. So a bit more other examples. The tiles can be clear, opaque, milky-like, green, the color that you wish. We can use pigments according to the client's request. In addition to tiles, we can produce tanks. It could be fixed tanks, not just, a fertilizer tank, for example, but it can contain, chemicals. It can hold chemicals, or any other industry that uses chemicals in its process. So we may produce by using a filament winding. So it's like winding a thread. It's quite similar, right? So the storage tank, the truck tanks to do transportation of chemicals, and so on and so forth. So I spoke about composites. A summary here to you. Why is it an advantage to use composites? In the US, there is this association, and they meet once a year. That's April 24th, to promote awareness on corrosion. So they address corrosion and its maintenance, the preventive maintenance against corrosion. This is what they address. And they believe that um, corrosion exceeds 3.4% of the global GDP. $2.5 trillion, it says on the slide. So they estimate global reduction could be 15 to 35%, saving from 375 to 875 billion per year. So we spend a lot of money in the world, a lot of money, really, with revamping because of corrosion. I'm talking about iron corrosion. Some materials are aluminum. There are some other materials that are made of wood. But let's talk about global maintenance. It's a high cost, right? It's a lot of rework if we do the math. And if we compare, steel with a composite, composite is more advantageous in most of the applications, okay? So composites, they are corrosion resistant. They're lighter to be transported. So you have savings on maintenance and you have a high durability of this kind of material. For agribusiness as well for civil construction or any other kind of a segment wherever we can use composites. Very well. That's what I had to tell you. This is my contact information. That's my invitation to you. Feel free to ask any questions. Don't be limited to this information here. I'll be available to provide additional information, and please visit us at the trade show. Thank you very much. Are there any questions for Anderson? Thank you.